Right, so today we're going to look at solving systems, as Mr. Roy said, using elimination. If you look in the book, they call it the addition method. Okay, same idea. Well, why do you think we're learning different ways to solve systems? Okay, we already have graphing. We already have substitution. Why do you think we need to learn a third way to do the same thing? Any thoughts on that? Oh, Maria? Sure. Logan? Why are we learning another way to do the same thing?
Is it more accurate?
All right, so I agree with you. In terms of graphing isn't always accurate. This method, like substitution, is always 100% accurate. Okay? We're not going to have to worry about trying to estimate an answer. This will be exact. Okay? Another reason why we're learning elimination is because different ways of solving a problem, we try to make it as easy as we can. Okay? Sometimes a problem it's easier to use substitution on. Okay? Sometimes a problem is set up where it's easier to use elimination. Okay? So what we're trying to do is come up with different methods that make the problem as easy as possible. Okay? It's kind of like if you're using a tool. Okay? You want to use the right tool to make the job as easy as you can. Okay? If I said, well, what tool would you use to cut something? Well, depends on what you're trying to cut. If you're cutting paper, maybe you'd use scissors. Okay? If you're cutting rope, maybe you'd use a knife to cut it. If you're cutting a tree, you'd use a chainsaw. Okay? So different tools make different jobs easier. Okay? Elimination is going to make certain jobs easier for us. Okay? So don't worry about substitution. Okay? The problem we just did on the MCAS. Okay, we're not going to do substitution today. All right. So when we solve using elimination, okay, we're going to look for three things.
And guys, today there's really no notes. It's just examples. Let's do an example today. We already talked about this.
Okay, so as Mr. Roy said, you're looking for two things. You're going to have the same number, and they have to have the same letter, but you want their signs to be opposite. Okay, one positive, one negative. Okay. The reason we want different signs is because that's going to cause things to cancel out. Okay, the goal of addition method, basically when we add things up, okay, they're going to cancel out. Okay, that's the goal. If we can cancel out one of the variables, then we're not going to have to worry about it. Makes the problem easier to solve. All right, so we've got a template, and you guys probably see this on your notes. Okay, so in the template, we have spots for each equation.
Guys, don't worry so much about writing this one down. We're just gonna go over this one together. You don't have to write it down.
Okay, we got spots for
You're gonna run out of space.
each equation.
All right, you don't have to write this one down.
Then we have where we're going to do our work. And then we have some other boxes to show you how we're going to solve for the other letters. All right, so if you look at these equations, do you guys see anything here that have the same letters, same numbers in front of those letters, and opposite signs? All right, same letter. Yep, they both have a 1. Now, are the signs opposite for the Y's, or are they the same? So which letters there have opposite signs? Yeah, the X's have opposite signs. Okay, so that's what we're looking for. Same letters, the same numbers in front. They both have a 1, but they have opposite signs. Okay, so what we're going to do is we're going to add these equations together. Okay, and we're just going to add them up in columns. Notice the X's are lined up, the Y's are lined up, and the numbers are lined up. Okay, we have to make sure that that's always true. Okay, and in the first few problems, it is. All right, Ryan, what do you get if you do X minus X?
Negative x.
Negative x. Or maybe think of it as x plus negative x. And you add two things that are opposites, like 2 plus negative 2, or 4 plus negative 4.
X.
If you have x and you take away x, you can't be left with much. What are you left with?
Nothing.
Nothing. So you're left with nothing. So when we add these equations up, x plus negative x, these cancel out. Okay? Any question on that? Those cancel out. Now let's add up this column. Right? Ben, what's y plus y?
2y.
Good. 2y equals. And Sam, what's 4 plus negative 2? 2. Okay, so now once we did that, notice what happened. We eliminated, that's why it's called elimination, one of the variables. All right? Now, last step, to get y by itself.
Yeah, so guys, once you solve going up and down, all you're doing is taking your problem and bringing it over. All right? Victor, Logan, Gage.
So Victor, how am I going to get y by itself here? Yep, by 2. Good. Divide by 2. Divide by 2. And what's 2 divided by 2? 1. Okay, so that's good. Now we know one of our answers. Okay, we know y equals 1. Okay. Any question on that? All right, now what letter do I still need to find? I still need to find x. So the last step is to plug the variable we just solved for, plug in 1 for y, into an original equation. Notice it doesn't say which one to use. You can use either one and you will get the right answer. So pick the equation that looks the easiest. Okay, let me just move my crossouts off so you can see them. Which equation here do you think is easier to plug into? Top one or the bottom one? How many said the top one? Yeah, I think the top one because you have a positive x, a positive y, and a positive 4. It's all positives. Okay? So I'm going to fill in that number right there. This part is kind of like substitution. Okay? Once you have one of the numbers, you plug it in and you find the other one. Okay? That's kind of like what we did before. So I've got x plus, now I'm not going to put y. What am I going to fill in? 1 equals 4. So what's my last step now to get x by itself? Subtract 1. And what's x? 3. Okay, and that's the whole method. Okay. This method works very nice as long as you have letters where you have the numbers that are the same, the letters are the same, and the opposite sign. Okay? That's when this method works nice. Okay? A problem like this is perfect for elimination. Same letters, same numbers, opposite signs. Okay? This one
you can copy down, guys.
This one you could do substitution with. Okay? Any of the problems we're solving with elimination today, you could solve with substitution or you could solve with graphing. We've set them all up so elimination is the easiest today. Okay? And if you get a problem on MCAS or a test in the future and it just says to solve, technically you can solve this any way you want. Use whatever method you think is easiest. Okay? But we're going to practice elimination. All right, so which letters here have numbers in front that are opposite signs?
-2, -2.
Good. So when we add these equations together, these y's are going to disappear. Okay, that's the whole goal of elimination. One column disappears. All right. So Gage, what do you get when you add up the first column?
3x.
Good. 3x. Okay, Sabrina, when I add the second column, negative 2y plus 2y, that's 0. So I'm not going to put an x on it because we need to see it later on to plug in. So I'll just, those cancel out. Equals 2 plus 1. Brian? Adding up that column on the right. 3. All right. Now, all we're going to do, so we have some more space, is copy this equation over into the second box. 3x equals 3. Brian, can you tell me my next step to get x by itself here? Divide by 3. Divide by 3. Now, put your answer right where these circles are.
X equals 2 over 3.
Which reduces to 1. Okay, x equals 1. Right, and now who can tell me what do I have to do with this 1? Yep.
Insert it in one of the equations. I suggest 1 because it's all possible.
All right, so Logan says take this.
No, not 1. I meant 2.
You want to plug it into 2?
Yeah.
All right. Again, as long as you did this step correctly, it does not matter which equation you pick. Pick the one that you think is easier. So Logan said, all right, I'm going to take 1, and I'm going to plug it in for x, and he picked the second equation. All right, so we got 2 times 1 plus 2y equals 1. Okay, Corey, what's 2 times 1? 2 plus 2y equals 1. Okay, I'm going to subtract 2 from both sides to cancel out my 2. And Alex, what's 1 take away 2?
Negative 1.
Negative 1. And my last step, I need to move that 2 to the other side. And how about Zach? How are we going to move that 2 over?
Divide.
Yep, by 2. And there's our answer. Okay, just write it in the bubbles, circles. Y equals negative a half. Okay, so very nice method as long as these numbers are opposites. Works very nicely.
So guys, in a problem, we're doing these kind of problems, right? We're doing elimination. What do we have to look for first? What are we looking for first? Same what? Same number. What else? Same letter. What's the most important thing? Different sign. Right? We look for that first. When we get that, Victor, we get that same number, same letter, different sign. What are we going to do? All right. Somebody help out Victor. What are we going to do? What are we going to do when we find that same number, same letter, different sign? How come, like the math we're doing in this first step, how come that's different from what we've, obviously it's a different method, but think about the direction. How is that different from what we've done in the past? What do you think, Justin? How is that, over here in this first step, how is it different from the math we've done in the past this year? Think about the direction you're doing your math in.
Justin, I think what he's asking is, we took equation 1, we took
Yeah.
equation 2, and what did we do with them?
Added them.
Yes.
Yeah, remember, we're working up and down here, right? So once we find that same number, same letter, different sign, we know we can cross it out. Or just know when you do your math, when you're doing your math here, all right, for this to work, one of those variables has to be gone. You got to get rid of one. And by having same number, same letter, different sign, that's going to do that. That's what we had. That's what we had in that last one. Okay? Do that. Then it's like substitution again, right? The one that you saw. Once you do that, the one you solve for, plug it back in. That will give you 1. Then pick another equation, or pick one of the equations. Either one doesn't matter, and plug in that other letter. All right? So you're like kind of once you're done this middle box, you're substituting to get the other variable, right? The answer to the other one. Okay?
All right, let's try this one. It does have some fractions. I'm going to hope that in the end the answer works out nice. We'll see. Make it a little bigger if you can't see it. Okay, at least I do see something here with the same letter, same number, and opposite sign. Anybody tell me, and you can think of it as a column. Column 1, column 2, column 3. Which column has same letter, same number, opposite sign? Yep.
The R.
Yeah, the column with R in it.
Guys, one variable is R, the other variable is S.
So when we add up columns with the same number, same letter, and opposite sign, what happens? Go ahead, Logan. Yeah, they just cross out. Okay, when we add these equations together, the first column is going to cancel out. All right, let's use our calculator to add 2/5 plus 4/5. Okay, so 2/5 is 0.4. 4/5 is 0.8. So I'm just going to do 0.4 plus 0.8. Oops. 0.4, 1.2. 1.2, and which letter is that? 1.2, S. Okay, we got to be careful. I don't like to use S a lot, but just try to make sure your S looks like an S. Okay, if I make a 5, I'll try to make it look like that. I know they look similar, but all right. So 1.2S equals 45 plus 15. How much is that? 60, good. And my last step to get S by itself, you know, I'm just going to put it in parentheses because it does kind of look like a 5. I don't want you to be confused. Okay, divide by 1.2. Oh, you know what? Normally we copy that over here, so I'll finish it over here. Okay. Mr. Roy and I aren't going to be overly picky where you do your work. It's just this template makes it easier for you. Okay? If you do your work here like I started to, that's fine. Okay? Just make sure when you're done you have both answers. All right. So we're going to do 60 divided by 1.2. Right, so what did we get for S? $50. S equals 50. All right, now which equation here you think is a little easier to work with? Top or bottom? Yeah, Brian? Yeah, I like the top one. Everything's positive. Okay. And Ben, which number am I going to plug in, or what number am I going to plug in into that top equation?
50.
50, and for which letter?
S.
For S. All right, so we've got 1/2 R plus, okay, I'm going to use my calculator to do that, 2/5 times S. So it's 2/5 times 50 equals 15. All right, let's figure out what's 2/5, and then we'll multiply it by 50. 0.4. Okay, 2/5 is 0.4 times 50. It looks like we are going to get some nice answers for this problem. 1/2 R plus 20 equals 15. Okay, Jalen, how would I move the 20 to the other side?
Subtract 20.
Good. I'm going to subtract 20. Subtract 20. 1/2 R. 15, take away 20. Good. -5. And does anybody remember when you have a fraction in front of a letter, what you do on both sides? Perfect, exactly. Yep, you're going to multiply by the reciprocal. 2/1. 2/1.
So it's just a 2.
Yep, so what's -5? It's just really a 2. What's -5 times 2? Yep, -10. Okay, so in all those problems we just did, everything was already lined up
Yep.
very nicely for you. R's, S's, numbers. Okay, that's how it has to be every time you want to use elimination. It doesn't matter if the R's are first or the S column is first. Just make sure all the R's are in one column, all the S's are in another column, and so on.
Yeah, make sure your letters are all on one side of the equal sign, then just have a regular old number on the other side of the equal sign. So letter, equal sign, number.
Okay. Does everybody have this third box? Okay. Right. So this is what we just said to you guys. Step 1 was already done for us, okay? Having to line everything up. Okay? So now we're going to try a couple problems where we have to line things up. All right, so based on that, can anybody tell me what's different about example 2A?
The numbers aren't lined up in the same columns.
Yeah, things aren't lined up. Okay, like Mr. Roy said, you want all the X's on one side, all the Y's on the same side. You want the numbers on the other side. All right, so let's do this one.
Guys, so for this one, when you rearrange your stuff, you might want to put it underneath it.
All right, so let's rearrange what we need to rearrange. Okay, we've got 2x equals 3y minus 5. What needs to move to the other side here? What do we have to move in this equation first? Yeah, we've got to move the 3y. Okay, we want the x on the left, that's good. We want the constant on the right, that's good. But we want the y on the left. Okay? Who can tell me how I move that y to the left? This is a plus 3y, so think opposite. What's the opposite of plus 3y? Yep. Negative 3y, negative 3y. What's on the right-hand side by itself now? Negative 5. And what's on the left-hand side? Ryan? Remember, are these variables the same? So we can't combine them. We pretty much just have to rewrite what we have right there.
Okay, so just 2 over here.
2
Minus,
x
minus 3y.
minus 3y. So that's my new first equation. Okay? Now it looks just like the other ones. Number with x, number with y. On the right-hand side, number by itself. Okay? So I'm going to put that. Well, let's just put it. We'll put it right here. Just trying to think of a good place where there's room. You can put it wherever you want, but that's fine. All right. And now, still below this, let's take this bottom equation, and we have to fix this one as well. 3y equals 4x plus 1.
What's in the wrong place, guys? You can tell me. Which thing is in the wrong place?
X.
The X is in the wrong place, right? Victor, what are you going to do to get that X in the right place? Should it be, obviously we know it's in the wrong place. It's on the right-hand side of the equal sign. So where should it be?
On the left side.
On the left side. Good. How am I going to get it there? Good. Is it going to go before the 3y or after the 3y?
Before.
Good man. So
Yeah.
what should Mr. Hager write on the left-hand side of the equal sign? You got it.
Wouldn't be 4 actually.
Well, close. You're missing one thing. How'd you move it? That's a fact, and that's what it's
Negative 4.
negative 4x. What about that 3y?
So it's
Is it positive or negative?
positive.
Positive. Perfect. That's it. And guys, that's like as tough as it today. That's as tough as it gets. Most of the time, it's going to be all set for you to find. You're going to find a thing to eliminate. This one, he's going to rearrange himself. That's as hard as it gets. There'll be one just like that on the homework.
All right, now the hope is after doing that, we can look at a column and see same letter, same number, opposite sign. By rearranging, did we end up with a column, same letter, same number, opposite sign? Yeah, which column? The ones with the X's or the Y's? The Y's. Okay. So now it's just like the problems we did in example 1. Okay. Gage, what do we get when we add up the first column?
Oh, never mind. You get a negative 2x.
Yep. Okay. Logan, how about when I add up the second column?
You don't because they're opposite sides. So they're opposite sides, so you cross them both out.
Yep. So the Y's cancel out. And negative 5 plus 1 is negative 4. Okay, now we don't have any room, so we definitely want to copy this into the second box. Okay, my last step for X. Okay, how about Maria? It's my last step here to get X by itself. Yep, I'm going to divide. And Alexis, can you tell us what we're going to divide each side by? Good, negative 2. So the 2's cancel. Negative divided by negative is positive. That also happens on that side. Negative divided by negative is positive. That's 4 divided by 2. Yep, Callan just said it to me, 2. All right. Now, just like we've done before, we can pick either equation 1 or equation 2. Just go back to this box. Which equation do you guys want to fill in for? Equation 1 or equation 2? 2? Okay, what are we going to fill in for? The x, and what are we going to fill it in with?
Negative 2.
Positive 2. All right, so let's do that out and let's see what we get. 3y. What's 4 times 2? What, Jan? 8. 4 times 2 is 8. Plus 1. 8 plus 1 is 9. Okay, and about Ryan? Last step here to get y by itself?
Divide.
By 3, good. So 9 divided by 3 gives me 3.
So guys, that problem that we just did, how is that one different from like the previous 3 that we did? Someone tell me by raising their hand. How is that one different from the previous 3 we just did? Actually, I'm gonna call on Gabe. Gabe, how is this one different from the previous 3 we just did? Think about that first step. Not sure? All right. Jalen, what was different from this one from the other ones we've done? Think about the ones we did before that. We found a different sign. We found the same number. We found the same letter. We were all set. How's this one different? Exactly. We had to rearrange. What? Someone tell me. What do we mean by rearrange? What should it look like, Maria? Say again? What'd you say, right, Hager? You're not wrong. You said, tell me what you said.
You have to set them off in columns and have the same each.
Exactly. What on the left hand side? What do we want? What should be on the left hand side? What should be on the left-hand side of the equal sign when we're doing these? Variables, numbers, animals. Variables should be there, right? Remember, we want the variables on the left-hand side, the equal sign. What should be after the equal sign? What do you think, Corey? After the equal sign, what should we have? Variable? No, what should we have? Just a number, just a plain old number. That's all it's going to be. And guys, on the test, all right, on Friday, it's always going to be X and Y. We're not going to give you any S's or T's or W's. It's always going to be X and Y. Okay? So there's one in the homework that's like this too, where you have to rearrange. All right, just one. So keep that in mind.
All right, let's try one more where we have to rearrange, and then I think we have 2 word problems. Maybe we'll just do one of them together and let you guys do one if we have time.
Okay.
All right, let's see. All right, look at this problem. Is this one set up the way that we want? No. Okay. Something here is already set up the way we want, so this one's actually going to be a little faster than the last one. What equation here is already good? We don't need to mess with it. Yeah, the first one. X, Y is already where you want it, so we don't have to mess with the first equation. 4x minus 3y equals 3. How about the bottom equation? What do we have to do in the bottom equation? 7x equals 19 minus 3y. Kevin?
We have to add 3y.
Good.
Okay.
Add 3y. Add 3y. So now I've got 7x plus 3y. What's by itself on the right now? 19. Okay, so let's write that equation and hopefully something cancels out. 7x plus 3y equals 19. Okay, which letters there are going to cancel out? The x's or the y's? Yeah. -3, +3. They cancel each other out. So the y column is gone. Okay. In the x column, we have 7 plus 4, which is, what's 7 plus 4? 11x. And 3 plus 19 gives me 22. Okay. Copy that equation over so we got a little more space to do our work. Okay, to get x by itself, I'm going to divide each side by what number? 11. Good. So x equals, what's 22 divided by 11? 2. All right. Now, which equation, Logan, which equation here is easier to plug back into?
The equation 2 has 3.
Equation 2?
Yeah.
Okay. Again, it doesn't matter which one. Just pick whichever one you think looks
No,
easier.
Equation 1 because it has lower numbers.
All right. We'll do equation 1. All right. So when I plug in x, I have 4 times x, but x is 2. So what's 4 times 2? 8. Take away 3y equals 3. All right. Next step. Okay, Brian, how do I move this 8 to the other side? Yep. Perfect. Yep, I like it. Subtract 8 from both sides. And then 3 take away 8 is how much? Yep, negative 5. And it doesn't look like this one's going to come out to a nice answer. We're going to get a fraction. Okay. Divide by negative 3. Divide by negative 3. And does 3 go into 5 evenly? No. So what we're going to do is we're just going to write our answer as negative divided by negative is a positive. 5/3. Okay, so don't think you're wrong if you get a fraction. Fractions come up. Okay? But in general, Mr. Roy and I are going to try to make it so the fractions aren't too bad. Okay, so they're not too bad. Okay, any questions on that before we look at our last problem? All right, so whenever we learn a new method, we'll usually do some problems just like this, and then we'll try one word problem. Okay, just one. All right, I'm going to let you guys pick. Do you want to do the problem about the 2 packages? Or do you want to do the problem about Lupe and Juanita? Lupe and Juanita? All right. All right, if we have time, we can go back and do the package one. If not, we'll skip over it. All right, what do you think? What do you think our 2 letters should be here? L and J. Okay. If you want to use X and Y, go ahead. But I think I would use L and J, probably capital L, so lowercase l doesn't look like a 1. Lupe, Juanita. Lupe has $9 less than Juanita. Okay? So Lupe's money, how would you represent 9 less than Juanita? Okay, be careful here. First thing I would think of is when you think less than, what symbol do you think? Add, subtract, multiply, or divide? Justin? Yes, we're going to subtract. Just be careful where you put the J and the 9. You want to think Lupe has Juanita's amount decreased by 9. Think of it that way. Yep.
Would it be J minus 9?
Good. Okay, that's a little tricky sometimes. Okay, when you see less than, even though the 9 is first, it comes second. Okay, we've talked about that. Second equation. Together, they have a total of $53. Okay? If you're finding out how much money they have together, what are you going to do with Lupe's money and Juan's money together? Logan?
Could you do L plus J equals 50?
Yep. L plus J equals 53. Does everybody see where Logan got that from? Lupe's money plus Juanita's money adds up to $53. All right. Now, when we look at it, make sure your equations are set up the way they are, or the way they should be. Okay. Equation 2. Does that one look like it's ready to go? Yeah. Letters are on the left, numbers on the right. So we can leave that one alone. How about equation 1? Is equation 1 set up the way we would like? No. Nope. What needs to move to the other side? Good. We're going to move that J to the other side. Yep. By subtracting. So subtract J and subtract J. Okay. If I do that, Zach, what's on the left-hand side? Yeah, it's just L minus J. We don't have any numbers yet, so we can't combine that. And on the right is 9. Okay, let's copy that up above and see if something cancels out. So L minus J equals 9. Okay, there's our first equation. Here's my second equation. L plus J equals 53. And now, does anybody see a column there that when you add them up, they cancel out? Yeah, the second one. Negative j, positive j. Okay, with elimination, that always has to happen. Okay, so we'll make sure when we set up a problem that that always happens. Victor, what's L plus L? Yep, 2L. Negative j plus j. Remember, those cancel. What's 9 plus 53? 62. Okay, so copy that equation into our second column. 2L equals 62. Okay, Logan, what's my next step?
You divide 2L by 2, and then divide 62 by 2.
Yep. And Gage, what's that going to give me?
Oh boy. 62.
Yep, divided by 2.
I have no clue.
31.
Maria?
31.
Good, 31. Okay, I'm just going to put the dollar sign there because Lupe equals $31. And now this time, I think either equation is pretty easy to plug back into. But you want to do equation 2? All right. So I'm going to fill in $31 for L. So 31 plus J. Oops, I keep writing 5 when I mean J. Equals 53. Okay. What's my last step to get J by itself? Yep, subtract 31. When we do that out, 3 minus 1 gives me 2. 5 minus 3, 2. Okay, so Lupe has $31 and Juanita has 22. All right, so that one's a little bit harder because you guys have to make up the equation first and then solve it. Now, if you guys make up an equation and then you line it up and you're like, wait a minute, I don't have the same number, same letter, and opposite sign, then what that means is you probably didn't set up the equation right. Because Mr. Wright and I have made each problem, so I guarantee you something cancels every time. All right, so your homework tonight will be on a worksheet. Okay, but don't pack up yet because we'll give you some time to start that, and we've got some other examples to look at.
Sure, Daddy.